So good morning, everyone, and welcome to today's lecture. This is lecture number 2 in current, and we will try to wind off current in this particular session. In the last session, we had seen resistance and resistivity and different types of formulae of resistance and resistivity. Do we remember those formulae? Yes or no?
Yes.
We started with mean free path, drift velocity, relation between drift velocity and current density and electric field. You remember all these formulae? We had solved some questions based on this. Do we remember it? We had seen what is Ohm's law. I current is directly proportional to V. The graph is drawn between V and I. R is the proportionality constant. Do we remember this?
Yes, sir. Yes, sir.
And we had also seen that Ohm's law is not universal. Those bodies or those substances which follow Ohm's law are known as ohmic substances. If they don't follow ohmic law, they are known as non-ohmic substances. We had seen what is resistance. We had seen resistivity. We had seen the temperature relation between resistance at 0 degree Celsius and resistance at T degree Celsius. We remember these formulae.
Yes, sir.
That will take us to today's class. And today's class begins with this. The first question is this. Two wires of resistance R1 and R2 have temperature coefficient alpha 1 and alpha 2. These are joined in series. What is the effective temperature coefficient of resistance? I'll give you a minute to give me the answer. And the answer is what?
Option C, sir.
Option C. They are joined in series. Those are effective resistance R equivalent becomes R1 plus R2. Yes or no?
Yes, sir.
Now, if this is the original equivalent resistance. If I want to find out the value of R dash, this will be equal to R1 dash plus R2 dash. Yes or no? Where R1 and R2 would be the resistance at a higher temperature. Do we understand this?
Yes, sir.
So that will become equal to R1 into 1 plus alpha 1 into delta theta or delta t plus R2 into 1 plus alpha 2 delta theta. Do we understand this?
Yes, sir.
This can be written in this fashion. R1 plus R2 can be taken common and it can be written as 1 plus R1 alpha 1 plus R2 alpha 2 divided by R1 plus R2, this entire thing multiplied by delta theta. Do we understand this?
Yes, sir.
Now this will come in the original form. If I call this as R dash, this R dash will be equal to R original into 1 plus alpha into delta theta. That means this entire thing that we see here, becomes your effective alpha for the series combination. Yes or no?
Yes, sir.
So that is the correct option. Remember this question. If this question comes in your exam, don't have to solve this. You can straight away mark it and move ahead in life. Shall we move ahead
Yes, sir.
with the next question? And the next question that comes is this one. From the graph between current and voltage shown, identify the portion corresponding to negative resistance. Negative resistance. where will you have negative resistance? As I told you, VI graph may not be a straight line. If it is a straight line, it is known as an ohmic substance. Here it is not a straight line. For some reason it is straight, some other it is not. Where do we have negative resistance?
CD, sir.
CD. This is the only portion where the graph has got negative slope. This is not a VI graph, this is an IV graph, but even if it is an VI or IV graph, negative slope will mean negative resistance. The slope of VI graph gives you R, the slope of IV graph gives you conductance. Do we remember this?
Yes, sir.
The only place where the slope is negative is the portion CD, and CD is your correct answer. That takes us to the next question, and the next question is this one. Many questions of this type has come even in the last session. I saw a couple of questions in different sessions based on this. A wire of length L and resistance R is stretched so that the radius of cross section is halved. What is the new resistance of the wire? Radius of the cross section is halved. I'll give you a minute to give me the answer. It's very sad, but it is on expected lines that you have forgotten what we had done in the previous class. Well done. This is what we had done, stretching of wire. R1 by R2 is R2 by R1 raised to the power 4. Obviously, we have forgotten it. So it's the time to wake up. And the answer for this one is 16 R. Radius is halved. Area becomes 1 by 4. Length becomes 4. 4 divided by 1 by 4. 16 times. The resistance becomes 16 times. Congratulations that you have forgotten what we had done in previous class. If we forget what we do one day before, how the hell will we remember what we are supposed to do 3 months from now? That is why you get all these revolutionary marks in the exam. Congratulations. Anyways, I must leave this sarcasm and move ahead in life. There's no point of there is a saying in Hindi, भैंस के आगे बीन बजाने से कोई फायदा नहीं होता. There is no point singing tunes in front of a bell, in front of a buffalo. She will not understand it. She will not understand the importance of music or what I am reciting here. She will not understand it. So no point of saying anything to you. You are all useless. Anyways, God gives another chance. This is the next chance that you have to redeem yourself. I always believe that children are like cash vouchers. They can redeem. Time for redemption. Remember, a simple mistake costs you very dearly. A question of this nature, whatever question we see in JEE, they are very simple. If you do a simple mistake, that may even cost you your selection. That may definitely cost you a dear college. That can definitely cost you a dear branch in a dear college. May God give you enough wisdom to understand what we are doing wrong and what we have to rectify. The VI graph for a conductor at temperature T1 and T2 are shown in the figure. T2 minus T1 is proportional to what? Well done. So we have redeemed ourselves. Redemption lies on the path. Temperature T1 and T2. What is T2 minus T1 proportional to? Now this is a VI graph. And we know the slope of VI graph gives you resistance. And resistance is directly proportional to temperature. Yes or no? So resistance at temperature 1, R1, is proportional to T1, and that is proportional to tan of theta. Ting, 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 ting. Resistance R2 will be proportional to T2, and that is proportional to this angle is given as theta. So the angle with the x-axis is tan of 90 minus theta. So T2 minus T1 will be proportional to cot theta minus tan theta. And from here, I think you should be able to solve it. This is a simple trigonometric equation, and you will end up somewhere with cot 2 theta. That you must be able to get it from here. If you can't get it, well, I will not say anything from here onwards. This is the next question coming for you. Redemption. The resistance of a wire at 20 degrees Celsius is 20 ohms. 500 degrees Celsius is 60 ohms. At what temperature will the resistance be 25 ohms? Option D, 80 degrees Celsius is correct. So, to do this, you must remember this formula R1 by R2 is 1 plus alpha 1 into delta T1 or T1, 1 plus alpha is same. Why I'm writing alpha 1 and alpha 2? Even my brain is not working properly today. It seems like alpha into T1 divided by alpha into T2. So I put it once. 20 divided by 60 is equal to 1 plus alpha into 20 degrees Celsius divided by 1 plus alpha into 500 degrees Celsius. Do we understand this?
Yes, sir.
From here, you will get the value of alpha. What is the value of alpha you are getting?
1 by 240.
1 by 220 is the answer that you should get. That is given in my sheet. 1 by 220, and I will not comment on this. If you can't calculate this, I don't know what you can do. We'll move ahead and write the second equation. Original at 20 degree, the resistance. Oh, let me write it the reverse way out. That will be better. At the resistance is 25 degrees Celsius divided by 20 can be written as 1 plus alpha is 1 by 220 multiplied by temperature is T divided by 1 plus alpha is 1 by 220 multiplied by 20. From here, you should be able to calculate this. If you can't calculate this, I don't know what you can do. 80 degrees Celsius is what you will end up with. That is the answer, my dear friend. You should be good in calculations. I have told you from the very first day that we started this session and class, and I always find you wanting on that front. And the only thing that you have to improve on, and still there is time to improve 3 months. You can improve your calculation in 3 hours if you so desire. Desire is what you need, my dear friend. Desire to improve your calculations. Your calculations are sick. I have not seen weaker calculations in the entire universe than the students of this generation. That does include you and everyone else. Your calculations are sicker. At your age, I used to look at this question and I would have marked it. This is the answer. All the calculation in my head. In 5 to 10 seconds, I could have done this.
Sir,
Not,
alpha
I can't do it now. But you
1 by
have to
2.
improve on your calculations. If you can't improve on your calculations, you will not be able to score quickly. Yes.
Alpha is 1 by 240 only, sir.
Okay. In my sheet, it might be written wrong. Are you getting T as 80 degrees Celsius or not?
Yes, sir.
There might be a printing mistake. I've given it to a person who would have typed. He would have typed it wrongly. Doesn't matter. I can't comment on my calculation at this stage in my life. But I'm very bad at calculations now. This is the next question. A rod of certain metal is 1 meter long, and this is just to check your calculations because I've been insisting so much on calculations. A disc of the same metal is 1 mm thick and 2 centimeter in diameter. What is the resistance between the circular faces? 2 minutes you have. Option A. The answer that I have does not have option A as the option. Okay. So I need to do the needful. This question even did not have so much of calculation. This was a rod. The first rod is 1 meter long. The diameter is 0.6. The distance rho L by A. The first resistance 3 into 10 raised to the power minus 3 is equal to rho into length is 1 meter divided by area is pi into 0.3 square. The second resistance is R, that will be equal to rho into a disc of same metal is 1 mm thick. Same question came in JEE. This attempt, they asked you the moment of inertia of this disc. Now they are asking you the resistance of this disc. Rho into length of this disc 1 millimeter, 1 into 10 raised to the power of minus 3 divided by 2 centimeter in diameter. So 1 centimeter is the radius. Pi into 0.1 square. It is in centimeter, but I'm just finding out the ratio. So they will cancel out each other. This is not even a calculation. I don't even call it a calculation. The answer is B. It's as simple as this. If you have made a mistake, see where you have made a mistake. This was a rod. If you can call this as the disc. The thickness of this disc was 1 mm. And this was the radius or diameter of the disc, 2 centimeter. And I've already told you how to find out the resistance between 2 points. So everything in this question was known to you. Okay. Do we understand this?
Yes.
You must work on your calculations better. You must work on your memory. You have to remember things and you have to calculate them fast. If you just can't do it, you will not be able to score highly. And from what I see, and I was just making the table of that percentile versus marks from the information that I've got. Even if you, and this is the table that I have made in different sessions. If I talk about physics, to get 99.5, percentile, you were needing somewhere around 77 to 84 marks. For 90 percentile in physics, the marks should have been somewhere around 42, 35 to 42. In maths, the numbers were drastically low. For 90 percentile in maths, the marks could have been even 10, 12. That is what I have got from the research that I have done. One question, 4 marks. Your percentile falls drastically in physics. As I was discussing with you, Karthik, you said that you have attempted so less in maths, still your percentile was high. That was correct. From the information that I have got, 95 percentile in maths in different shifts that I see. What was your shift?
31st second shift.
31st second shift. The 95 percentile is somewhere around 20 marks. I think you would have got 20 marks, 24 marks. That was 95 percentile. So, marks matter. One wrong question. In physics, if I talk about 31st second shift, 99.5 percentile was 89 marks. You drop 4 marks, you go to 99 percentile. You drop 10 marks and you go to 96 percentile. And that's a big, 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 big drop. Anyways, length of a hollow tube is 5 meter, its outer diameter is 10 centimeter. I can obviously make this question without the calculation, but I want you to do the calculation, and that is why this question is put. Length of a hollow tube is 5 meter. I can call the length as L if I just want to solve this question algebraically. Its outer diameter, I can call it as D. Thickness of this wall, I can call it as T. The resistivity of the tube, I can call it as rho. What is the resistance of the tube? So you can give the answer. You should give the answer in terms of R, L, rho, and D. Also, you should give the answer in terms of putting the values and getting the answer. Time passes on. Let's see if you can give me the answer. With this question,
Sir, option D, sir.
Option D. Just give me a minute. Okay. So the answer is option D. That is correct. How are we supposed to get this one? The distance is rho L by A. The wires are probably of the same material because it is not given. So we'll assume them to be of the same material. Now, remember this formula, rho L square by V. I can write it like this. Yes or no?
Yes, sir.
Area is written as volume divided by length. So I can write it like this, rho L square by M into D, where D is the density of the wire. Yes or no? Volume is mass divided by density. Do we understand this? So I can say R is directly proportional to L square by M. I hope you have done this in this manner. Yes or no?
Yes, sir.
So R1 is to R2 is to R3 will be equal to L1 square by M1 is to L2 square by M2. Remember all these questions because these questions are in fashion these days. The first one is 25 by 1. The second one is 9 by 3. The third one is 1 by 5. And the ratio is coming same as this one. Do we understand this?
Yes, sir.
Everyone understands this.
Yes, sir.
Then I have this question for you. And I hope you can give me the answer first. Option B, sir, is the correct answer, sir. We just have to find out the distance between the rectangular faces. And if I talk about the rectangular faces, this has two faces which are square faces and the rest four are rectangular. Do we see this? Yes or no?
Yes, sir.
So we have to find out between if I call this phase as phase number 1, then the piche wala phase will become phase number 2. Yes or no? So
Yes.
resistance will be equal to rho L by A. Yes or no?
Yes.
Here L will become how much? L will become 1 centimeter. Do we understand this?
Yes, sir.
And the area is the area of this phase. And the area of this phase will be 100 multiplied by 1. If you put these values with the correct units and the correct powers, because this question is all about unit and powers. If you are putting it in the correct unit and the correct power, then only I am going or you are going to get the correct answer. Do we understand this?
Yes, sir.
One last question that will cover all type of questions that can come in this particular section. This is the one that we are looking at. The following figure shows the cross-section area of three long conductors of same length and material with square cross-section areas. So the area of cross-sections are given. Conductor B will fit snugly within conductor A and conductor C will fit snugly within conductor B. What is the relation between the end-to-end resistance? I hope you have understood the question. Yes or no? No or yes?
Yes, sir.
Let's see if you can give me the answers for this one. The resistance of these rods will be equal to rho L by A. Now, all the rods are made of the same material and they have the same length. So, rho L are same. You just have to look at the cross-section area. Do you understand this?
Yes, sir.
For the first rod, this is the cross-section area. You have to find out this area. For the second rod, this is the cross-section area. You have to find out this area. For the third rod, this is the cross-section area. You just have to find out this area. And if you just apply some common sense, you will understand that all the cross-section areas are same. Yes or no?
Yes, sir.
And that is equal to A square. Since all the cross-sectional areas are same, the resistance of all the three wires would be same. So RA will be equal to RB will be equal to RC. Do we understand this?
Understood, sir.
That takes us to the next heading, color coding, and we will do it fast. I hope all of you know this. Yes or no? Color coding of resistances.
Coding, decoding.
Now, whenever you get a resistance, the resistance of the resistor is not written straight away. It is written in the form of a code. This code has four letters A, B, C, and D. Do we understand this?
Yes.
Might not have seen this, but you might know this. The first two letters tell us the first two numbers or the first two significant digits. Color band A and B gives us the first two significant figures. C gives us the power of 10 and D gives us the percentage error. Do we know this? Color band A and B indicate the first two significant figures. C gives us the decimal multiplier and the last band gives us the tolerance level or the error level. If it is gold, then it is 5%. If it is silver, then it is 10%. If it is no color, then it is 20%. Tolerance means the error. Do we understand this?
Yes, sir.
Everybody understands this. For example, if the resistance of this resistor is written in this fashion: 42 into 10 raised to the power 3 plus or minus 5%. Then you must understand that this letter A will give you this value 4. Do we understand this?
Yes, sir.
Green code will give us the value of 2. C code will give us the value of 3. And D code will give us the tolerance percent. Do we understand this? I'll give you 2 minutes to note this down. Then that takes us to this color code. Black has color code of 0, brown 1, red 2, and so on. The way to remember this is this: B.B. Roy of Great Britain had a very good wife. B stands for black, the other B stands for brown, then red, then orange, then yellow, and so on. Do we remember this? Just note it down. I'll give you 2 minutes
Yes.
to note it. And this is the question: draw color code for 42 kilo ohm plus or minus 10%. What will be the color code?
Sir, yellow, red, black, and
Yellow, red,
black.
black.
Oh, kilo. Sorry, sir. Orange, sir.
By reading, everyone can tell me. Yeah. Yellow, red, orange, and silver would be the color code for this one. What is the resistance of this one?
EBOI under 4, sir. Into 10 power 7. Sorry. 420 plus or minus 5. 447. 420. 420 ఉండదు ఐదు 10 పవర్ వస్తుంది. 440.
Hey Bhagwan, so much time to calculate this. It will be 47 into 10 raised to the power 1 plus or minus 5%. What to do, what not to do. Only two things that you need to improve on. One is your memorizing skills, and definitely your calculating skills. Well, chance for redemption.
Sir, option D, sir.
Thank God we have redeemed ourselves somewhat. Redemption, 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 redemption. Let's see if you can recollect something here. These type of questions are in fashion these days. Electrical cable consists of a single copper wire of radius 9 meter. 9 mm. Meter is too much. Its resistance is 5 ohms. This cable is replaced by 6 insulated copper wires, each of radius 3 mm. What is the resultant resistance of the cable? This is from series parallel combination of resistance. We are doing questions which we have not done previously. You have 2 minutes to show your talents. and redeem yourself. Students are like cash vouchers. Sometimes they might not get redeemed. Not because cash voucher is faulty, because the person who is putting the digits is faulty. And the answer is option A. So basically what you have to understand here is one cable which was like this has been replaced by 6 different cables. Do we understand this?
Yes, sir.
Now these 6 different cables across these points, are they connected in parallel or are they connected in series? They are connected in parallel. Yes or no?
Yes, sir.
The resistance of this wire is rho L by pi into 9 square. Yes or no?
Yes, sir.
The resistance of this wire R dash will be 1 by 6 rho L by pi into 3 square. Yes or no?
Yes, sir.
From there, you can find out the relation by dividing, and I think the answer that you are going to get is 7.5 ohms. Do we understand this, or this has gone above our head? Saying bye bye. One
Understood.
last time, bye bye. Bye bye.
Understood, sir.
Do it fast then. Next question. Coming on your screen now. Two resistors R1 and R2 provide series and parallel combination as n is to 1. So series combination is n, parallel combination is 1. So what is the correct relationship? I'll give you 2 minutes to get the answer. And the correct answer is option D. Well done. So series combination R1 plus R2, that is the series combination. That is R series. Do we understand this? R1 into R2 divided by R1 plus R2, that will be equal to R parallel. Do we understand this?
Yes, sir.
If I divide R series by R parallel, I think I will get this R1 plus R2 whole square divided by R1 R2. Yes or no?
Yes, sir.
And that is given as N. Do we understand this?
Yes, sir.
From here you can get, if I take the root R1 by R2 divided by root over R1 R2 is equal to root over N. Yes or no?
Yes, sir.
As soon as you see this, you end up with this result. Yes or no? No or yes?
Yes, sir.
Well done. If you have done this, that means you are improving with your calculations, and that is a good thing to note. Again, remember we have already done series parallel combinations, but I am just covering questions specifically with a resistance because I can see that these questions are in fashion these days. This is the next one. In a combination of resistance shown in the figure, the potential difference between the points B and D is 0. What is the value of the unknown resistance? You have 2 minutes to give me the answer. Answer is option B. 2 ohms. How you are supposed to get this? If the potential difference between these 2 points should be 0, what does that mean?
Wheatstone bridge.
Wheatstone bridge. So if I call this as R1, if I call this as R2, if I call this as R3, if I call this as R4, R1 by R2 should be equal to R3 by R4. Yes or no?
Yes, sir.
So 16 divided by X shall be equal to 4 divided by 1. Yes or no?
Yes, sir.
No, not 1, 1 by 2. Yes or no?
Yes, sir.
From here you will get the value of X as 2 ohms. Do we understand this?
Yes, sir.
Everyone got this?
Yes, sir.
Okay. We keep on going ahead, solving questions. This one, straight away, simple question. What is the potential difference between A and B in this question? I'll give you 2 minutes to give me the answer. Option B, sir, how did you get? Now, you should remember simple thing. This is 2 ampere current. It will get divided between the two branches, but you can see whether you talk about this blue branch or you talk about this green branch, both have the same resistance, yes or no?
Yes, sir.
So equal current will go, 1 ampere current will go here and 1 ampere current will go here, yes or no?
Yes, sir.
So I can write VD minus 2 into 1 will be equal to VA, yes or no?
Yes, sir.
Ohm's law or Kirchhoff law, whatever you call it.
Yes,
So
sir.
I can write VD minus VA will be equal to 2 volts. Do we understand this?
Yes, sir.
Similarly, I can write VD minus VB is equal to 3 volt. Yes or no?
Yes, sir.
From here, subtracting and dividing, you should be able to find out VA minus VB, and it is going to come as plus 1 volt. We understand this? Yes or no?
Understood, sir.
Okay. This is the next question. The resistance of each is 9 ohm. Find the reading of the ammeter. Ammeter reads current. Do we know this?
Yes, sir.
Okay. Yes. What is the answer?
Option A, 5 amperes.
Option A, 5 amperes. Anyone knows this? Current in each branch is 1 ampere. Yes or no? 1, 1, 1, 1, 1, 1, 1, 1, 1. Yes or no?
Yes, sir.
So from there you can find out the current in all the branches. This branch will be 1, this branch will be 2, this branch will be 3, this one will be 4, and this one will be 5. So 5 ampere current will come in this branch. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
And these type of questions. A wire has a resistance of 12 ohms. It is bent in the form of a circle. What is the effective resistance between 2 points across any diameter? Give you 2 minutes to give me the answer for this one. So how are you supposed to get this?
Sir,
Well, this is the resistor. The complete circle is having resistance of 12 ohms. So the upper half will have resistance of 6 ohm because it is half of the length, and the lower half will have resistance of 6 ohm. Do you understand this?
yes, sir.
Then this 6 and the other 6 will be in parallel. The effective answer would be 3 ohms. Do we understand this?
Yes, sir.
Then comes the next question. Now this is a general question. A wire of resistor R is bent in the form of a circular ring of radius R. Equivalent resistance between 2 points X and Y on the circumference when the angle XOY with alpha is how much? What is the equivalent resistance? So how are you supposed to do this? Let me call the resistance of smaller part as R1 and resistance of the bigger part as R2. What will be the resistance R1 equal to? Yes,
Alpha by 2 pi into R.
R into alpha by 2 pi. Yes or no?
Yes, sir.
The value of resistance R2 will be R into 2 pi minus alpha divided by 2 pi. Yes or no? Because the angle is 2 pi minus alpha. Do we understand this?
Yes, sir.
So the effective resistance between X and Y will be R1 multiplied by R2 divided by R1 plus R2. Yes or no?
Yes, sir.
If you calculate this, I think the answer that you are going to get will be option A. Are you getting this answer?
Yes, sir.
Yes or no? No, yes.
Yes, sir.
Now, there is a question where it's going to come in the next chapter. If I call this current as I, if I current goes here, I current will come out from here. Yes or no?
Yes, sir.
If I call the current in this branch as I1 and if I call the current in this branch as I2, can you tell me the value of I1 and I2? I'll give you 2 minutes to do this. Yes.
I1 is 2 pi minus alpha by 2 pi into I, sir. I2 is alpha by
I1 will be
2 pi minus alpha by 2 pi into I, sir.
2 pi minus alpha by 2 pi into I. Very good. And I2 will be
Alpha by 2 pi into I, sir.
alpha by 2 pi into I. That means the ratio of I1 by I2 will be inverse ratio. 2 pi minus alpha divided by alpha. Do we understand this?
Yes, sir.
Remember this because we might be needing this in times coming ahead. Do we understand this? Yes or no? No or yes?
Understood, sir.
Okay. Now we have already covered your EMF and cell. We will go through this EMF and cell once again. So you can write the heading EMF of a cell and EMF. We'll just go through it again because there are some things that we might have to do here in this, a cell or a battery. What is the purpose of a cell or a battery?
To create potential difference between 2 points.
To create the potential difference between 2 points. Why do you want to create that potential difference?
To allow the like
To allow what?
to allow
America
current
to
to pass through them.
huh?
To make current pass through, like flow through them.
For the current to flow in a circuit, you must need potential difference, and that potential difference is provided by the battery or the cell. Yes or no? There are two types of battery or cell. One is known as ideal battery, one is known as real battery. The EMF of the battery or the cell is the work done in moving a positive charge from the negative to the positive terminal. Do we understand this? Do we remember this?
Yes, sir.
It is also equal to the potential difference across the terminals of the cell when the cell is not connected. Do we understand this?
Yes, sir.
At the same time, apart from understanding the EMF of the cell, what might be asked in this chapter on electric circuits would be the potential difference across the battery. And what do you mean by potential difference across the battery? The potential difference across the battery the potential difference across the battery is the potential difference across these 2 points A and B. Do we understand this? The
Yes.
potential difference between across these 2 points is known as the potential difference across the battery. When the battery is in open circuit, this potential difference would be equal to EMF. If the battery is in closed circuit, this may be more than EMF. This can be less than EMF. If the battery is non-ideal, if the battery is ideal, it is always equal to the EMF. Do we understand this?
Yes, sir.
Do we remember this?
Yes, sir.
Ideal cell and real cell. We have already seen ideal cell and real cell.
Yes, sir.
Everyone is able to recollect what we are doing here. Ideal cell, no internal resistance. Real cell,
Internal resistance is present.
real internal resistance R is there. Do we remember this?
Yes, sir.
Then we had seen the two cases where the battery is getting charged or where the battery is getting discharged. When the battery is getting discharged, we say work is done by the battery. And if I multiply the potential difference across the battery, this is the potential difference across the battery, VA minus VB. Do you understand? E minus IR will be the potential difference across the battery. In this case, this will be less than the EMF. Yes or no?
Yes, sir.
The rate at which the heat is generated inside the battery will be equal to I square multiplied by R. The power output from the cell will be this one. Do we understand this? Note this down because this may come as question in your paper. I'll give you 2 minutes to give me to note this down. Everyone understood this?
Yes, sir.
And these are the other cases when the battery is getting charged, the potential difference becomes E plus IR. The thermal power inside the cell is I square R. The power output is this one. We understand this?
Yes, sir.
If the circuit is in, if the battery is in open circuit, we potential difference will become same as EMF. If it is short circuited, the potential difference will become zero. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Do it fatafat. The next heading that we are going to write is known as the maximum power transfer theorem. Now, what is this maximum power transfer theorem? In any DC circuit, we have a battery, and in most of the cases, this battery is not a real battery. This battery is not an ideal battery. This battery is a real battery, so it has got some internal resistance, which you can see as small r. E is the EMF of the battery. Do we see this?
Yes, sir.
Apart from this battery and its internal resistance, whatever is connected across the battery, in this case, this resistance R is connected. This could be a bulb, this could be a switch, this could be a lamp. This bulb, switch, or lamp is known as the load. Do we understand this? This is known as the load. Do we understand this?
Yes, sir.
Now, what is our prime concern or prime important for us? The point that is more important to us is we want to deliver the maximum power to this load. If it is a bulb or it is a fan, you want it to have the maximum power. Yes or no?
Yes, sir.
What is the condition for which the maximum power is given to the load is given by this maximum power transfer theorem? So what I have done is I have converted into a question and found out everything in this question: current, power output. You can also find the internal resistance of the battery. So we can solve it in different parts. We'll write all these answers together, and that becomes the summary of this entire thing together. Do we understand what I'm saying here?
Yes, sir.
You have 2 minutes to solve and get the answers for this one. I'll give you time, and then uh, one more thing you can find it here is the internal resistance R of the battery. Okay, forget about R. I will probably give it in a different thing. You can find out all these things. What things are known to you? E, small r, and capital R. Let us see if you can do this. I'll give you 2 minutes to solve each and every part. Well, let us start with the first thing, and the first thing is simply to find out the value of current, and this is the simplest question in the entire universe. What is the value of current?
E by R plus R.
The value of current would be E by R plus R. Everyone got this? Yes or no?
Yes, sir.
Power output. Whenever we talk about power output, we are talking about power which is given to the load. The power which is given to the load will be I square into R. Yes or no?
Yes, sir.
I square into R. So you just multiply this, square it, and multiply by it by R. You will get this. Yes or no?
Yes, sir.
For the third case, we had to find out maximum power. So maximum power, to get maximum power, this dP by dR we need to calculate, and then we need to equate it to 0. Yes or no?
Yes, sir.
Once you do that, the condition for maximum power will happen when small r is equal to capital R, and this is what you should remember. Small r would be equal to capital R, and this is what you should remember. For maximum power, the load must be equal to the internal resistance of the battery. Do we understand this?
Yes, sir.
Now, once you put the value of small r as capital R or capital R as small r, you will get the maximum power dissipated will be E square by 4R. Power maximum will be E square by 4R. Do we understand this?
Yes, sir.
First listen to me, then I'll give you time to write. If you draw the graph would look like this. This is the maximum power. How much is the maximum power? It is E square by 4R, and it happens when R is equal to R. Do we understand this?
Yes, sir.
This graph is symmetrical, so power will be same for two values of capital R, R1 and R2. And remember, R1 into R2, if you take the multiplication of R1 and R2, that will be equal to internal battery car resistance squared. So for these two values of R, capital R, the power would be same. Do we understand this?
Yes, sir.
Okay. And the last question was efficiency. To understand efficiency, we must understand what is the power given by the battery, what is the power which is given out from the source. Power given by the battery is E square by 2R. Power output is E square by 4R. Therefore, efficiency becomes how much? Your efficiency eta becomes 50% in this case. So for maximum power that this battery can give is only 15%. Only 50%. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Maximum power transfer theorem. And again, this thing here, the only thing you have to note, everything else is same. The internal resistance of this battery or cell can be calculated in this way: E by V minus 1 into R, where E is the EMF of the battery, V is the potential difference across the battery terminals, minus 1 into capital R. It's a very important result because this result would be used to find out the internal resistance of a cell using potentiometer. When we do that thing, probably we will do it today or maybe we will do it tomorrow. In that case, we will be needing this result. So that's why it becomes a very important result, because we will be needing it in the next class. Internal resistance of the cell. Rest all we have already seen. If you want, you can note it down. I'll give you 2 minutes to do this. Then you can note down these 2 points. Power maximum does not mean that the current in the circuit is maximum. Do we understand this? Current will be maximum when the external load is 0, but power is not maximum when the external load is 0. We understand this? EMF of the battery is independent on the resistance and only depends on the electrolyte of the cell. You might have read it in chemistry. Yes or no?
Yes.
Note it down fast. Then this is the next question, sir. A new flashlight, a 1.5 volt EMF, gives a current of 15 amperes when connected directly to an ammeter of resistance 0.04 ohms. What is the internal resistance of the cell? I'll give you a minute to give me the answer. So how are you supposed to do this? It's very simple. I will be equal to E upon R plus R. Yes or no?
Yes, sir.
I is given as 15 amps. Yes or no?
Yes.
E is given as 1.5 volt. Yes or no?
Yes, sir.
External resistance, here is the ammeter. External resistance is given as 0.04. Yes or no?
Yes, sir.
So from there you can find out the internal resistance R. Internal resistance R would be equal to 0.06. Do we understand this?
Yes, sir.
That is the correct answer, 0.06. Do we get this, everyone?
Yes, sir.
This is the next question for a cell. The terminal potential difference is 2.2 volt. Terminal potential difference means the potential difference across the battery. When the circuit is open, and it reduces to 1.8 volt when the circuit is connected. Closed with a resistance 5 ohm. What is the internal resistance of the cell? These questions are in fashion these days. 10 by 9 ohms is correct. How did you get it? R will be equal to E by V. R will be equal to E by V minus 1 times R. Yes or no?
Yes, sir.
So internal resistance R will be equal to the EMF of the battery is 2.2 divided by 1.8 minus 1 into the load resistance is 5. So this is how you can get the answer, and I think the answer that you are going to get is 10 by 9. Everyone gets this, yes or no?
Yes, sir.
This is the next question then. This is a question from the IIT-JEE of 1995. You want to deliver the maximum power to this entire network. What should be the value of R? Option C 2 is correct. Basically, the internal resistance of this battery is given as 4. So the total resistance of the circuit has to be 4. Yes or no?
Yes, sir.
Now, if you look at the circuit, this is a balanced V-stone bridge. This circuit goes out. So you can find out the equivalent resistance of this. What is the equivalent resistance of this coming as?
2 hours, sir.
It is coming as 2R balanced V-stone bridge. So 2R must be equal to 4, and after that the question is pretty straightforward. Do we understand this?
Yes, sir.
Yes or no? No, yes.
Understood, sir.
And the last one in this category, and here it comes, a torch bulb rated. Now, whenever we talk about a bulb rating, this is the power and this is the voltage. So from power, which is equal to V square by R, you can find out the resistance of this bulb or the cell, V square by P. Yes or no?
Yes, sir.
Remember this. Is connected as shown. The EMF of the cell needed to make the bulb grow with full intensity is how much? I'll give you 2 minutes to give me the answer. So how are we supposed to do this? Hmm? The bulb should glow with full intensity. That means the potential difference between these 2 points should be 1.5 volt. Yes or no?
Yes, sir.
That means the potential difference between these 2 points should be 1.5 volt. Yes or no?
Yes, sir.
The potential difference across the battery or the cell is 1.5 volt. Yes or no?
Yes, sir.
That must be equal to E minus I into R. Yes or no?
Yes, sir.
So your battery ka EMF will be 1.5 plus I into R. The internal resistance is already known, 2.67. Yes or no?
Yes, sir.
From there you can find out the current. You can find out the current, total current here in this circuit I. You can find out the total current. You can find out the current in this branch. It will be 1.5 ampere. Yes or no? Yes or no?
Yes, sir.
Can you find out the current in the second branch, this branch? Power in the cell can be written as V into I. So I can be written as V power 4.5 divided by 1.5. So this current will be 3 amperes and this current would be 1.5 amperes. So the total current will be 4.5 amperes. So 4.5 multiplied by 2.67. Do we understand what I have done here?
Yes, sir.
How did you get the answer that you got? Anyways, note this down. I'll give you 2 minutes to do this. So we move ahead into the next heading, the last heading for this, and the heading is electrical instruments, electrical measuring instruments. Electrical measuring instruments. What are the electrical measuring instruments that you have heard about? Yes. Have you heard about any electrical measuring instrument? Electrical instrument. You have not heard about any measuring instrument. Is that so?
Sir, potentiometer.
Straight away potentiometer. Nothing before that potentiometer. Okay.
Sir, ammeter, voltmeter.
Right. That is what we are talking about. Ammeter. What is an ammeter?
An instrument which is used to measure the current in the circuit.
Current in the circuit. How it is connected? It is always connected in.
Series.
So if I have to measure current in this branch, I have to connect the ammeter in series. Do we understand this? This is how ammeter is connected in series. It is denoted by the letter A. A stands for ammeter. Yes or no?
Yes, sir.
Now, whenever we talk about ammeter, if for an ideal ammeter, the internal resistance has to be 0, but it is not possible. Do we understand this?
Yes, sir.
So for an ideal emitter, the internal resistance has to be 0. It is not possible. Uh, Internal resistance is always there, and therefore the reading of the emitter, whatever reading that emitter takes, it always would be less than the actual reading of the current. Do we understand this?
Yes, sir.
Everyone understands this about the emitter? Unless it is mentioned, we will always take the emitter as resistance 0. If you have to take its resistance, the resistance would be given. If the resistance is not given, we will take the emitter as an ideal emitter. We understand this?
Yes, sir.
I'll give you 2 minutes to note this down. And we come to the next setting, which is a voltmeter. What is a voltmeter used for measuring?
Voltage or potential difference.
Potential difference between 2 points in a circuit. If I want to measure the potential difference between point A and B, which is nothing but the potential difference across the resistor R, what do? I connect a voltmeter across the resistor. How it is connected? It is always connected in.
Parallel.
It is always connected in parallel. For an ideal voltmeter, ideal if a voltmeter is connected in parallel, it will draw some current. Yes or no?
Yes, sir.
For an ideal voltmeter, that drawn current must be equal to 0. That implies the resistance of this ideal voltmeter must be equal to infinite. Yes or no?
Yes, sir.
So if a voltmeter is ideal, it should not draw any current. Do you understand what current I have drawn? This
Yes.
current. This current should be 0. Therefore, the resistance of the voltmeter must be infinite. If you want to make a very accurate voltmeter, its resistance must be very, very large. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. The next thing is galvanometer. What is a galvanometer? A galvanometer is a very sensitive device. It's a very sensitive device and it can measure very, very small values of current. It can measure very, very small values of current. In a circuit, it can measure very, very small values of current. The galvanometer is represented by this letter G. Do we understand this?
Yes, sir.
It can measure very, very small values of current in a circuit. It works on the principle that whenever a current is passed through or whenever a current carrying coil is placed in a magnetic field, it will deflect and its deflection would be directly proportional to the current. That is the principle of a moving coil galvanometer. If I write the formula for this moving coil galvanometer, the formula for this moving coil galvanometer looks like this. Bina, B-I-N-A, is equal to C phi, where what is Bina? B is the magnetic field, I is the current in the coil, N is the number of turns in the coil, C is the torsional constant, and phi is the angle rotated by coil. So basically we can see that the current in the coil will be directly proportional to the phi, the angle through which this coil rotates, and therefore even if a small current passes through this galvanometer, it will deflect, and therefore it is a very sensitive device and it can measure very, very small values of current. Do we understand this?
Yes, sir.
Do we understand this? Bina is equal to C5. Will you remember this relation? I'll give you 2 minutes to note this down. Then we must understand these terms as well. The first term is known as current sensitivity. How sensitive it is to current. So how much it deflects for a very small current. Per unit current, how much is the deflection? That is known as current sensitivity. A question came in this year, one of the sessions on voltage and current sensitivity. So the current sensitivity is given by phi divided by I. Phi is the deflection, I is the current. Voltage sensitivity is given by phi divided by V. So it becomes BNA by CG, where G is known as the resistance of the galvanometer or RG or whatever you call it. Do we understand this? Yes or no?
Yes, sir.
All these terms, all these definitions you must remember. Do we understand this?
Yes, sir.
Then there is a term which is known as the full scale deflection current. What do you mean by full scale deflection current? This is the maximum current that can flow through the galvanometer for which the galvanometer will give you full deflection. Do you understand the meaning of full deflection? If this
Yes,
is a
sir.
galvanometer, it will deflect completely from 0 to the maximum value. Do we understand this?
Yes, sir.
This is known as the full scale deflection current, the current which can cause the full scale deflection of the galvanometer. I'll give you 2 minutes to note this down. Then the last thing for today's class is shunt or shunting. Whenever we use the word shunt or shunting, shunt resistance, it is a resistance which is connected in parallel. Normally, a small resistance is connected in parallel to the galvanometer in order to control the current flowing through the galvanometer. Remember, a galvanometer is a very sensitive device. if a large amount of current flows through the galvanometer will malfunction and it will go boom. It will be destroyed. So we want to current. So we want to control the current that flows through the coil of the galvanometer. Therefore, we connect a small resistance in parallel to the galvanometer. That resistance is known as the shunt resistance. What are the merits of the shunt resistance? It protects the galvanometer from burning. It can be used to convert galvanometer into an ammeter, which we'll be seeing in the next class. What are the demerits? It reduces the sensitivity of the galvanometer. It reduces the sensitivity of the galvanometer. So galvanometer becomes less sensitive. Do we understand this?
Yes, sir.
Do we understand this? I'll give you 2 minutes to note this down. Well done, sir. Then what we'll do is we'll move ahead from this point onwards in the next class, and in all probability, we will be winding off your current in the next class. So that would be on Saturday. So from Sunday, we can start with the next chapter, which is magnetic effects of current. I hope you have understood what we have done today. Everything that can possibly come in your JEE main or JEE advanced, I have covered. If you just go through these questions, and if you get some time, half an hour or 1 hour, if you can solve the question from the sheet, that is much more than enough that you will require to clear your JEE. So I'll wind off this class here, and I'll see you tomorrow in the next class, and we'll be winding out current in the next class. Take care. God bless you. Bye bye.
Bye, sir. Have a good day.
Bye, beta.